Will AI help us create a warp drive? Could aliens even survive a trip to Earth? What would happen if you fire a powerful beam at a black hole? And in Q&A Plus, which part of the universe does the cosmic microwave background show us? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If the question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Jack C. Branch. Hey Fraser, given the danger from radiation, being in space combined with the vast distances, isn't it unlikely that any aliens would survive the journey to Earth? So traveling in space is extremely dangerous. And the radiation alone is something that you looked at. And, if you're outside of the magnetosphere of the Earth, you're experiencing hundreds of times as much radiation from cosmic rays than what you would experience just down on the surface of the Earth. Like, it's bad. Like, feel you full of cancer after a few years of traveling in space, bad. And that's just one issue, not to mention the long times it would take to be able to travel from star to star, the lack of resources that are available to you, the amount of radiation you're going to be producing from whatever propulsion system that you're operating. Like, these are all definitely big challenges for traveling from world to world. It doesn't seem surprising to me that you would be skeptical that like actual physical aliens in their biological bodies would attempt the journey to go from star to star. Like, unless they had warp drives and could do this instantaneously, or walk through a stargate where you're just like going for a walk around the park, but you happen to be on another planet when you come out the other side, and they all look like British Columbia, you don't go, right? There's no way you would want to make that kind of a travel. What if it took you 1,000 years to go to some other star system? Why would you leave the comfort of your own star system to make that kind of a journey just to drop in and visit? Right? You wouldn't. But what about the robots, right? The robots love to go to space. The robots don't care about radiation. They don't care about long duration times. I mean, they'll care a little bit about the radiation as the cosmic rays are wiping out their memory and causing problems in their electronics. But really, like, the robots are hardened to space. And so often the question that we should be wondering is not, where are the aliens, like, with their bodies? Why are they not here physically, little grays? But where are their robots? Where are the von Neumann probes? The self-replicating robot probes that can go from star system to star system, make copies of themselves, go to other star systems. Like, I would expect the von Neumann probes, I would never expect to see the aliens physically actually making the journey from star to star. Church discography. What would happen if a gamma ray burst slammed into a black hole? The black hole would absorb all of the energy from the gamma ray burst. So, like, a gamma ray burst is kind of the birth of a new black hole anyway. There's two kinds of gamma ray bursts. There's the short gamma ray bursts that last less than 2 seconds. Those are probably caused by colliding neutron stars. And then there's long gamma ray bursts, which are caused by the death of a massive star, something that is, like, really big, dozens, if not more than 100 times the mass of the sun. Thing collapses, you get a black hole at the center of it. And then you get this radiation that comes out like a supernova, but you also get these collimated jets of material that come out of the poles of the object as it is forming this black hole. And we know that even if one of these things hits the Earth from halfway across the Milky Way, it can cause severe damage to the atmosphere, wipe out a lot of the ozone in the atmosphere, let more of the radiation from space make its way into the planet through the atmosphere and cause damage to life on Earth. So they're really bad. But black holes can feast on energy, no problem. And so you would imagine, let's imagine like the perfect scenario. You've got this gamma ray burst, star collapses, blasts out this collimated jet, the collimated jet blasts, and a black hole happens to be perfectly in the path of that gamma ray burst. Well, the spread of the gamma ray burst is going to go much wider than the event horizon around the black hole. They have an angle of like 5 degrees. So imagine the sort of 5-degree angle coming off the gamma ray burst as it's sort of going out into space. So by the time you are several light years away, it's very big, while the event horizon of, say, a stellar mass black hole is going to be, well within the orbit of Mercury. So they're very small. But some of the photons, the gamma rays, coming from the gamma ray burst are going to hit the event horizon of the black hole. And they're just going to go right in, and they're going to add to the mass of the black hole using E equals mc squared. You just calculate the energy of the photons. That will help you calculate the amount of mass that the black hole absorbs, the equivalent amount of mass. And the black hole will get a little bit bigger. Its event horizon will get a little bit bigger, get a little more massive, and then it'll be a bigger target for future gamma ray bursts. So no, black holes can totally handle gamma ray bursts. Yum, yum. Ash D. While we're on the Lagrange points, would a binary star system have a different set of Lagrange points? The key to having Lagrange points is that you need to have two masses that are dramatically different by several orders of magnitude. To get a Lagrange point, you need to have one object that is very massive, and then an object that is a fraction of that mass that is orbiting around it, and that gives you the Lagrange points, which are these stable places. And so if you have two binary stars that are orbiting around each other, you don't have that disparity in their masses. Now, binary stars can behave like a single massive object once you are sufficiently far enough away from them. So, if you've got two stars, they're orbiting around each other, when you're really close, then the gravity is this tangled mess that if you get too close, you're just going to go into one of these stars. But if you get far enough away, like 2 to 4 times the distance, the separation of the stars, you can orbit around them stably. A planet can orbit around. It's called circumbinary planet. And so it can orbit around both stars of the binary system in this stable way. And then Lagrange points are back in play, although they probably get a little weird just because, the two stars are orbiting around each other. So it's not exactly a perfect point of mass, but if you get farther enough away, then the Lagrange points will come back into play. Neil von Holtum. How much longer do we have to wait until AI explains how to make a warp drive? You could probably get an AI to explain how to make a warp drive right now today. If you spend enough time stewing in its sycophancy and hallucinations, you could probably get the AI to start telling you that your ideas about a warp drive are 100% rock solid. And all you need to do now today is just build a prototype. And I get probably an email a week now. Maybe less, maybe an email every 2 weeks from somebody who is telling me that they have developed an idea for a warp drive because of their working with an AI, with ChatGPT, and all they need to do now is build a prototype. Well, the build the prototype part is the part that matters, that no amount of thinking about an idea about folding space-time and hashing it out with ChatGPT is going to get you to an actual working warp drive. You actually have to build the thing. And then right away, you will find out all of the flaws and the shortcomings of how the system works. But, the question you're asking is how long until it actually can help us make a working warp drive? And I've said many times in the past that the fact that we don't see any alien civilizations with working warp drives today tells us that we will probably never be able to build a warp drive. But, who knows? Maybe there is a design for a warp drive, or we're alone in the universe and then we're free to build warp drives. So you're going to need a lot of stuff happen where the AIs can actually innovate. They can actually come up with ideas, engineering ideas, scientific concepts, come up with ideas that extend beyond the repository of knowledge that humanity has gathered together. And the AIs can't quite do that yet. They can take ideas that have been explored really well in sort of one area, and then they can extend that across, or they can apply tools to turn something that, someone just hasn't gone through the entire search space to figure out yet. They can go through that search space and come up with novel solutions to mathematical challenges and things like that. But, to actually physically build a prototype, we are quite a ways away from just that kind of stuff in general. And then specifically building things that could very well be impossible, that's going to be a couple of years after that. So I'm going to say, I want to joke about this, but the technology is changing so rapidly that I do feel like we are all that sort of frog in the hot water pot, although that analogy is both awful and apparently incorrect, but that we passed the Turing test and nobody really cared. You remember when we used to think, it'll be crazy when AI passes the Turing test. And here we are today, and the AIs absolutely passed the Turing test. If you don't know, you would know that you're talking to an AI, or the average person would know they're talking to an AI. And so the technology is advancing, and the technology is starting to be used to make the technology better, and it has this flywheel. So who knows? I think we're probably 5 years away from AI being able to be innovative in making scientific concepts that have never been seen before, but then actually turn those into physical things. Maybe that's like 5 years after that. And then to make a warp drive, 5 years after that. So, maybe 15 years away. It's time to shout out our new patrons at the $5 level and above. Chris Brossard, Ian Moxham, Lyle Fisher, Alan Bloom, Anthony Hermans, Darren Nolan, Luke Anderson, Joachim Ekblad, Tess Tickles, and Christoph Renaud. Join our community at patreon.com/universe today. Luke Skywalker. My daughter asks how black holes are made. All right, so I don't know how old your daughter is, but I'm going to assume that she has an intellect that scales beyond anything we can scarcely imagine. So she can handle what I'm going to be spinning. Why are stars stars? And they're stars because they are in this balance. So you've got gravity that is pulling the star in on itself, wants to collapse that star into itself. But then you also have the light pressure pushing against the inward pull. And this is amazing, right? Like at the center of stars, they are mashing hydrogen into helium. They are making heavier elements. And as they do that, it produces gamma radiation. And that gamma radiation, these photons that are bouncing around inside the star, push out against the star, stop it from collapsing in on itself. As a star, like a big star, gets older, it uses up all of the hydrogen in its core, and then it switches to turning helium into heavier elements. It can turn things into carbon and oxygen and neon, and it just keeps making heavier and heavier elements in its core. All the while, it is producing this gamma radiation that is pushing against the gravity that's pulling the star in. And it gets all the way up to iron. And iron is this very special element that when you make iron, you don't get the gamma radiation in the way that you did with all of the other elements before that. And so now there is no radiation that is blasting out of the center of the star in the same way that it was there before. And now there is nothing holding all of that gravity that was keeping that entire star out. It all just collapses in on itself, implodes. And it can go like 70% the speed of light as all this material is falling inward. And you get this black hole forming at the center of the star because it's just being compressed down, where you've got all of the mass of this star just collapsing in on itself. And that's how you get a black hole. J. Chelu to be. We keep looking for life in the universe. Maybe we should focus on just making life that can survive in space. Should we embrace the opportunity? Well, why choose? Why can't we both walk and chew gum? They are two separate things. One is observing the universe to find out if there's life out there. And that is a very important question and could have real implications for our existence down here on Earth. Like imagine if we received a transmission from an alien civilization, or we saw evidence of an alien civilization having a nuclear war, or we could detect the presence of gases in their atmospheres, or we find some kind of ancient robotic factory here in the solar system. That would be interesting. And then we could study the technology and learn about it. So we want to search for evidence of life. And then maybe we should focus on just making life that can survive in space. Like that's a thing that we're going to be doing as well. We are transitioning into a solar system spanning civilization. We are building rockets capable of taking us to the stars. We have robots that are crawling around on other worlds right now. We are getting better and better at mastering the challenges of living and working and exploring space. And they are mutually exclusive. They have nothing to do with each other. Unless we find the alien factory in the asteroid belt and we need to build a mission to be able to go there, then yeah, the technology of us being able to fly in space will teach us about space. But like, I never understand when people have this, you should just do this one thing. Like we do all kinds of things, right? You should only watch one television show ever, right? Don't play video games. You are only meant to watch television shows or YouTube videos. In fact, you're only meant to watch my channel. Do not watch any other channels and really don't participate in any other media at all, or even talk to other people. All you should be doing is watching Fraser's videos. No, we do all kinds of things. And we do that as a, some people, we're not just one person. We contain multitudes. And some of us want to search for aliens, and some of us want to go and live in space. And money can be spent on both. And instead of the money that gets spent on military equipment or lawn care, did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And we call that Q&A Plus. And this week's bonus question, which part of the universe does the cosmic microwave background show us? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you everyone who put your questions into the YouTube comments, everybody who joined me for the live stream. We do live stream every Monday at a different time around the world, which I'm going to talk about in more detail in a second to kind of explain the new plan for the live streams. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finga, David Giltonen, David Matz, Evan.pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Buck, Brink Haidu, Richard Williams, Sean Sargent, Stephen Foundlemonley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldebor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we're trying a new experiment. And this is that we are now posting our live streams that we do every Monday live. So in the olden days, the days of yore, YouTube used to kind of punish you with its algorithm if you had longer episodes on your channel that were of a lower production quality. And so you would have like a lower watch time on the video, and then YouTube would take that into account for the rest of your videos. And then it would just bring down all of the stats across all of your videos. And so we decided, well, we'll do the live streams every Monday, and then we'll make them unlisted, and then we'll chop them up. We'll put in lots of high quality graphics and music and text and make it look really good. And then that's what we'll release so that we don't get punished by the algorithm. And it sort of feels like the tides have turned a bit. And so things are a little more conducive to being able to post long live streams here on YouTube. There's a lot of people doing longer videos who thought, okay, we'll give it a shot. And 2 weeks ago, we left the live stream live and did a little bit of sort of editing, new thumbnail, new title, and it seemed to work really well. And actually, we got a lot of people watching the live stream. And I know like a lot of you missed the live stream and you wish you could just watch it. And we do post a link in various places, but this makes it easier. So now it will show up automatically if you're refreshing the YouTube homepage. But now the pressure is on that we have to make the live stream higher production quality. So now we're going to, in the process of trying to make this thing kind of tighter, better quality, better graphics, and then still cut it up and make it available as a podcast and the other QA's version. So there's going to be kind of repetition on the channel, but you can like watch the full long one without all the graphics, or you can watch the shorter version. It's up to you. But hopefully a lot of you who were missing the episodes before will now be able to watch them every week. And I know like a lot of you took advantage of that last week. And so we've done it again for the second time, and we should be doing this from here on out. So give me your feedback. Let me know if you like this, how we can make it better. Whatever we can do to make your space and astronomy educational experience better, you just let me know. All right, we'll see you next time.